Block 1. The Hidden Architect of Gender, Nettie Stevens and the Chromosome Secret. Hello, and welcome. Prepare to uncover one of science's most profound yet often overlooked revolutions, the discovery of what truly determines whether we are male or female. This isn't just a story about chromosomes. It's the dramatic tale of a brilliant woman, Dr. Nettie Maria Stevens, whose meticulous work cracked the ancient code of sex determination, fundamentally reshaping biology forever. Yet her name was nearly erased from history. In this video, we'll journey back to the early 1900s, explore the thrilling detective work involving mealworms and tiny chromosomes, expose the injustice of the Matilda effect that stole her rightful acclaim, and celebrate how her legacy is finally being restored. Get ready for a saga of genius, perseverance, and the quest for scientific truth that still resonates in every genetics lab today. So, who was Nettie Stevens? Born in 1861, she was an American geneticist whose relatively short life, ending tragically at just 50 from breast cancer, was packed with extraordinary achievement. Defying the limitations placed on women in science, she was a stellar student, compressing a 4-year course at Westfield Normal School into just 2 years while graduating with the highest honors. Remarkably, she began her formal scientific career relatively late. After years teaching to fund her education, she earned her PhD at Bryn Mawr College in 1903 at the age of 42. This late start didn't hinder her brilliance. Instead, she became incredibly prolific. Despite dying just 9 years after receiving her doctorate, she published an astonishing 38 to 40 groundbreaking scientific papers. Her work ethic and keen intellect were undeniable. She even played a pivotal, often uncredited role in introducing the tiny fruit fly, destined to become the superstar model organism of genetics, to the lab of her former professor, Thomas Hunt Morgan. Morgan would later win a Nobel Prize for work heavily reliant on the very organism Stevens helped bring to his attention. Her own achievements earned her significant recognition for the time, including a prestigious $1,000 prize from the Carnegie Institute and the Ellen Richards Prize. Her most earth-shattering contribution came in 1905 while meticulously studying the humble mealworm. Through careful observation of their cells, Stevens noticed a fundamental difference between males and females. Males produced sperm of 2 distinct types, half carrying a large chromosome and half carrying a much smaller one. Females, however, produced eggs all containing a single large chromosome. Stevens made the brilliant, revolutionary leap. When an egg was fertilized by a sperm carrying the odd chromosome, it developed into a female. But if the sperm carried the X chromosome, a male developed. This tiny chromosome she identified became known as the Y chromosome. This wasn't just an observation, it was the first irrefutable proof linking a specific inherited characteristic, sex, directly to a particular chromosome. Her discovery finally resolved a centuries-old scientific battle. Was sex determined purely by heredity or shaped by environmental influences like temperature or nutrition? Stevens provided the definitive genetic answer: heredity, encoded in chromosomes. Her work became the critical, experimental cornerstone supporting both Mendel's laws of inheritance and the emerging chromosomal theory of heredity, theories that form the bedrock of modern genetics. Tragically, Stevens' brilliant deduction was quickly overshadowed. Another scientist, Edmund Beecher Wilson, published very similar findings almost simultaneously. For decades, credit was shared between them, or worse, Wilson often received primary or even sole recognition. However, modern historical analysis reveals a stark injustice. Careful examination of their work and timelines strongly suggests Stevens reached her conclusions first and independently. And, crucially, her evidence and interpretations were often more precise and comprehensive. Historians now argue Wilson likely refined his own conclusions, seeing Stevens' meticulous results. This blatant under-acknowledgement of Stevens' pivotal role is a textbook example of the Matilda effect, the systemic pattern where the scientific contributions of women are diminished, ignored, or attributed to their male colleagues. For much of the 20th century, Stevens' name faded into obscurity, while textbooks lauded Wilson and others. Yet the tide is turning. Increasingly, historians and scientists are recognizing the magnitude of her contribution. Her legacy is being actively reclaimed. She was inducted into the National Women's Hall of Fame in 1994, and in 2017, the Dr. Nettie Maria Stevens Science and Innovation Center was proudly opened at Westfield State University. Her story is a powerful reminder of the hidden figures who shaped our understanding of life itself.